to our YouTube channel. Today we are going to see the LeetCode problem, that is daily challenge problem, and the problem number is 1671, and problem is minimum number of removals to make mountain array. Okay, so first we will see what is mountain array. Okay, so mountain array is something like that. For any particular index I, and we have to start from 0 till that I, every number should be like, it should be increasing sequence, and after that it should be decreasing sequence. Okay, so what it is saying, like 1 2 3, then it should be 2 3. This is a mountain. 1 3 4, this is not a mountain because there is no decreasing sequence, there is a only increasing sequence. There should be a decreasing sequence as well. So for that, minimum length should be greater than or equal to 3, obviously, otherwise it can't be mountain, right? So for a mountain it should be like, the minimum case scenario should be 1 4 1. This is the requirement, ultimate requirement. Itna to chahiye, like we need this thing. Okay. Okay, so let's go further. Now we have an array. Okay, now we can delete few number of elements such that it can become a mountain array. So let's say this is the example 1 5 2 3. Okay, now we need to remove the elements such that it can become a mountain array. Is it a mountain right now? No, it is not a mountain. So to make this mountain, what we need to have? 1 5 2, or we can have 1 5 3. This is a mountain, this is a mountain. So in both cases we need to delete one element, right? This is the thing we need to find out. Okay, so let's see the first example here. In first example we have 1 3 1. Is this a mountain? Yes, it is a mountain already. If it is a mountain, we don't need to delete anything. We don't need to delete anything. That's it. It's done, right? Okay, so let's see this example. Second one, 2 1 1 5 6 2 3 1. Okay, let's try to find out the mountain. Okay, so mountain will be like, we need to have increasing sequence. So one possible increasing sequence can be here 2 5 6. This is the increasing. Now we can have 3 1. This is one possible sequence. Or you can have 2 5 6 3, no, 3 1. 3 1 is the only thing. Or we can have, instead of 3, we can have 2 1. This is also a valid mountain, right? This is increasing, this is decreasing. This is also a valid mountain, right? So we need to find the valid mountain scenario. We don't need to find like how many valid mountains are possible. We need to find like one mountain such that like there will be a less number of removals. Currently this is not a mountain. If you see, if you stay at here, is it increasing? No. If we delete these elements, two elements here and this element here or this element here, it will be increasing. Now it is decreasing. Perfect. So for that purpose, what we need to find? We need to find something, right? So let's see what we need to find. There can be a peak at any point of time. At any point of time there can be a peak, like either this can be a peak, this can be a peak, this can be a peak. So let's assume this is a peak. let's assume this is a peak. Now we will go left side and we'll go right side and try to find, is it possible, so we will go on left side. Is it possible? No, at this point it is not possible. Okay, so let's have the marker here. It is not possible. Perfect. So let's go here. Check from here. There is an element smaller than this element? No, it's not possible. Okay, let's go further. Now we are at this point. Is it possible now? Let's try to find out. So 2 5, yep, one possible sequence. Yes, 2 5. Let's write 2 comma 5. It's a one possible sequence. Now from the right side we need to find the decreasing sequence. Is there something possible? Yes, I can see 2 1 is a possible sequence. 2 1 is a possible sequence. Is it a mountain? Yes, it is a mountain. But how many elements we have removed to make this as a valid mountain? So we have removed this one, 2, and this 3, and this 4. We have removed 4 elements. Okay. Now let's consider this is the peak value. If this is the peak value, let's try to find out from here. So is it a valid sequence like 2 or 5 then 6? Yes, it is a valid sequence. We can write 2, 5 and 6. Now go in the right and find the decreasing sequence. Decreasing sequence can be 2 1. Now how many elements are there? 5 elements. How many we have removed? We have removed this, and we have removed this 3. How many elements we have removed? 3. Now check. There is a mountain, and how many elements we have removed? 3 only. Earlier we were removing 4 elements. So what is the minimum? Minimum is 3. This is what we need to return. Return the minimum number of elements to remove to make nums a mountain array. Okay. So we will consider this condition only. Perfect. No problem at all. That's it. Now our goal is to calculate this thing. Like, how can we calculate? We should know na ki what is the increasing sequence, what is the decreasing sequence till this point. Right? Now let's see the constraints. Constraints are 10 raised 3. That means we can easily go n square. Right? We will go n square. So now at any point of time, we need 2 things. One is LIS. What is LIS? Longest increasing subsequence. And from right side, what we need? LDS. What is this? Longest decreasing subsequence. If we know these 2 things, we are good. That means like we know this. Now what we need to remove? We need to remove the remaining elements. Let's say we have 2 here, 3 here. So we have 5 elements. Now we need to remove the let's say total elements are 8. So 5 elements are there. We need to remove 3 elements only. Right? This is the thing. So we need to calculate this LIS and LDS. I have already written LIS and LDS here, but we will calculate here again so that you can understand how these values are coming. Okay. So let's move them down. Okay, and we will write this 2115. Okay. 2115, or better 2115 6231. 2, 3, 1. These are the elements. Okay. Now we will try to build first LIS. Okay. So for LIS, we need something. We need to store. Let's say if this is the only element, this is already a increasing sequence, right? Only element will be a increasing sequence always. No worries at all. Okay. So also okay. So we will fill initially every value to 1 only, because we know this is 1, this is 1, this is 1, this is 1, 1, or like let's change the color so that we readable 1, 1, 1, 1, 1, 1, 1, 1. Okay. Now let's say you are starting from this point I. Is there a sequence in the left side? No. So we can't go, right? So let's go here. Is there a sequence in the left? Yes, there is a sequence. So we will try to find. We'll go from here. This is the J pointer. We'll try to find if this value, the value at ith pointer, is greater than the jth pointer. If it is greater, that means our sequence is increasing, right? So this is not increasing. So we will move further. I is here, J is here. Is it increasing? No, it is not increasing. We will move RJ. Is it increasing? No, it is not increasing. That's it. That is the end. Now we again move this I. Now J is at this point. Is it increasing? Yes, it is increasing. So what is the current value? And we are adding one value to it. This is the increasing sequence, right? So we need to take the maximum of at this point. What is LIS of this point? Okay. So this is 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Okay. 0, 1, 2, 3. At third index, what is the value? It is 1. Now we are including this element. So what is the what is the increasing sequence till this point? It is 0. This is 0. So it is 1. So we need to take the maximum of this value, LIS of J, and now we are including this value. So plus 1 comma LIS of I. We need to find the max value out of it. What is the max value? Okay. This is the third index. So third index we have 1. This is 1. What is this? It is 1. 1 plus 1 is 2. Now this is increasing. Nice. So let's increase the value. Make it 2. Is it correct? Obviously. You can check here. There is only 2 values are possible. 2 and 5. This is the only possible increasing sequence. Not more than that. Okay. Now let's increase this J to here. Is this value greater than 1? Obviously, it is greater than 1. Okay. If it is greater than value 1, then we need to again do this. Now, LIS of 1 is 1 already. 1 plus 1 is 2. This LIS of this 3 is already 2. So what is the value? 2. Now you can check, like either sequence can be 2, 5 or 1, 5, but both have length 2. So there is no difference in it. So we will not update anything. It will be a 2 all. Okay. Now we are at this point. The same scenario happened. Nope. We can't increase. Now we need to increment are ith pointer at this point, and jth pointer will be starting from here. So jth pointer here, the value is 1. There is no increasing sequence from the left side, right? So we'll update this value is 1. So 1 plus 1 and 1, what is the maximum value? 2. Do this, go here, what is the maximum value? Like here 1 plus 1 and 2 is already there, so we will not update. Go here, we will not update. Now come to this point here. Till here there is a already, like 2 length is already possible, like either it can be 1 5 or 2 5, but 2 length is already possible. Now this element is smaller than this element, that means this element can be like included in this sequence, right? So 2 length is already there. Now this is a new element we are adding, so it will be 3. So at this point, this lis of j, this will become 2 plus 1, and this value we have already 2. So what is the maximum? 3. Put this 3. Make sense? Now we'll go further. This is the end. Now I is at this point and this is I. Now we'll go from here. This is not increasing. At this point this is increasing, so we'll update this value. It will be 2. This is same, this is not increasing, this is not increasing. That's it, done. Now move further. This is I. Now go from here. 2 3, it is increasing, yes it is increasing. Update this value. 1 5, 1 3, is it increasing? Yes, but what is the sequence? 1 and 3, like at this position it is 1, so we are adding one more element to it, so it will be 2 only. That is fine. 1 here, same thing. Now 5, at 5 is this increasing? Nope, it is not. At 6, is it increasing? No. At 2, at this point, jth, now we can see here we have already a 2 length, like 1 and 2 is already possible. Now we are adding one more element, so what is the length? Length will be 3. Now we'll add 3. Perfect. This is the end. Now we'll go again. J is here, I is here. Starting from here, it is increasing, no, it is increasing, no, it is increasing, no, it is increasing, no, it is no, 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 till the end, no. That's it. So this is the sequence. If we compare, like we have 1 1 1 and 2 3 2, 2 3 2, then 3 again, then 1. This is the correct we got. You understood the approach, like what is happening here. We are going any point, and we know till this point this is the already increasing sequence. Now we are adding one more element to it, the length will be increased by 1, so that's why we are doing plus 1. Okay, now we'll do the same thing, longest decreasing sequence. Now we need to find this also. Now earlier what is happening, we are going from start. Now what we'll do, we'll going from the end. Same thing, right? So okay, so let's try to build this array as well, so that we are in better shape to go with it. Okay, this is the same thing. Now we'll start from here. I is here, j is not possible, so we'll move our I to here. Or first we need to draw this. Okay, now we can fill the values. Initially all will be 1. This is also 1, this is also 1, this is also 1, this is also 1. Now check this. is this value greater? Yes, it is greater, and we have already 1 here. So at this point, this can be a 1 3. This can be a sequence of 1 3. So we need to update this value. Instead of 1, we need to update. It becomes 2. Perfect. And this is the only thing possible here till this point. Now we'll update our I. I is now at this point. Now go from here. Is it a valid sequence? Yes, 1 2 is a valid sequence. So till here it is already a 1 element. Now we are adding 1 element more. So it will be a 2 only. Perfect. Now J comes here. Is it a valid sequence? No, we can't include this. It should be increasing from the, like we are going from right to left. So it will be increasing. It is not increasing. Right? So it is not possible. So okay. So let's update our I. Now I is at this point. Starting from here, is it increasing? 1 6. Yes, obviously it is increasing. So we'll make this 2. Now we are coming to this point 3. Is it increasing? Yes, we can add this element. But we need to find out how many elements are there already in this sequence. So at this point we have already 2 elements. That means 2 elements. We are now adding the third element. So it will also be increasing, right? So we'll update this to 3. Now we are coming at this point. It is the same thing, because at this point we have a value 2. Now we can add 1 element to it. It will become 3. So 3 is already there. We are not buried. Okay. Now proceed further. We are at this point. Now we are at this point. Okay. Go. I go again. 1 5 is the valid sequence. Yes, it is a valid sequence. Perfect. So let's update the value to 2. Now 3. 3, like it is a valid sequence. Like 5 is greater than 3. Perfect. We at 3 we have already 2 elements. Now we can add 1 more. So it will be 3. Now we are comes here 2. We have a sequence of 2. It is the same. 6. Can we add 6, like 5 element after 6? No, it's not possible. So we will not touch this. Now we'll move further. So this I will be at 1. Now go from here. Is there any element that is increasing? No, nothing. No sequence is possible. Okay, fine. Same for this. Fine. Now come to this point directly. I. Perfect. Now let's see. Go from here. Is it increasing? 1 2. Yes, it is increasing. Let's add it. Let's add it immediately. Okay. Now go here. Is it increasing? No. It is increasing? No. No, no, no. At this point, yes, it is increasing again. But at this point, there is already a 1 element. So we need to have again. So we can't include, because 1 plus 1 is already 2. It is there. So we don't need to have this. Okay. Now check the sequence. Now check the sequence. It is 2 1 1. It is 2 1 1. Then we have 3 3 3 3 2 2 2 2 1. Perfect. This is what we got. Now from here we need to find the sequence, like answer. We need to find our answer. Okay. Now let's calculate the answer. We know at any point how many elements, like increasing sequence from the left side, decreasing sequence from the right side. We know. Now we can compute the answer. Perfect. So let's have this. 1 minute. Perfect. Let's go down. Okay. Now let's say you are at this point. At this point, how many left are possible? How LIS the max length is 1, and what is the right length is 2, right? Right length is 2. So now we have how many elements in this sequence are possible at this point? It is not possible because this is not a valid scenario on the left side. We will not consider this element. Okay. So we are at this point. We are at this point. It is again 1. Not possible. Not possible. Now we are at this point. Okay. Now we'll try to find out the what is the LIS of it. LIS of it is 2. Like 1 5 or 1 2. Okay. What is LDS of it? LDS of it 3. Now if you see, we have taken, let's say, 1 5 from LIS and LDS, let's say we have it is 3. So let's say we have taken 1 2 5. So 5 2 1. So we have taken one extra element, duplicate element, 1 5 5 2 3 1, right? This is extra element. So we need to remove one element because that is duplicated. Done. So now how many elements we have in our sequence? 2 3 5 minus 1, that is 4. This is 4. Now to achieve a sequence of length 4, how many elements we need to remove? So total elements are 8. Now we need to remove 4 elements. Perfect. 4 elements, that is our answer. But this is the answer at this point. Now we'll check again. Like let's say if this is the peak, then can answer be reduced? Can answer be reduced? We need to find the minimum. Obviously, try. Let's go further. At 6. At 6, we are at 6. So what is the LIS possible? LIS possible is 3. 3. Perfect. What is the LDS is possible? It is again 3. Now one element is duplicated. Like how? Well, let's say 1 5 6. This is the sequence we have, and here we have 6 3 1. This one is duplicated. This element is duplicated. We need to remove one. Okay, let's remove. How many elements are there? 5. To achieve the length of 5, how many elements we need to remove? We need to remove 3 elements. Right? Total elements are 8. We need to have this length 5. So we need to remove 3 elements. So is this minimum? Yes, it is minimum. So answer will be updated. Answer will be 3. Now go further. Now I is updated again. This is calculated. Go here. Is it possible to reduce? I don't think so. Let's see. Okay. So at this point we have 2 from LDS also. It is 2. The length is 4. But we need to remove one element as well. So that is 3. Now to achieve a length of 3, we need to remove 5 elements. 5 is minimum. No, obviously we have 3. Why do we remove 5 elements? No, we will not do this. Okay. Same goes again. I is okay. We'll move further. Okay, I is now here. Is this like we have 3? LIS is 3 from here, but decreasing sequence 2. So how many elements? Total will be 4 elements we have. 4. Now like to achieve 4, we need to remove 4 elements. This is not minimum. And again at 1, this is not possible. Like this is no sequence possible. So we have our answer as 3. This is our final answer, and this is the answer you can see here. Now we will see the code. We have completed our dry run. Okay. So we need two things. What is one? LIS, LDS. Okay, two vector. Initially values are having 1. Perfect. Now we need to fill. This is for LIS. We need to go from starting. This is what we were doing, right? Go again, jth pointer. Now if this value nums of I is greater than nums of j, that means this is a valid increasing sequence, right? We can add one element, so we are adding one element to the earlier possible sequence and updating in our ith pointer. Perfect. This is the LIS. Same goes for like LDS. Now we are going from the back side, right? Increasing sequence from back side, that will be a longest decreasing sequence. Same thing, go from back side, ith pointer. Same goes for jth pointer. If it is greater element, that means that is a valid increasing sequence from the back side. If it is valid, update it, right? Perfect. Now we need to calculate the minimum removals. Initially we define int max. Why? Like minimum element. Okay. So what we'll do, we'll go from I equal to 0 to I less than n, and if it is possible, if LIS of I is greater than 1 and LDS of I greater than 1, if it is possible, that means that we can remove the elements, right? At that point we can remove the elements. So how many elements can we remove? What is the sequence here, what is the sequence here, and what is this value? The current value, it is calculated twice, that's why. So now we can get our minimum removals. That's it. This is our answer. We got our answer. Okay, that's it. So what is the time complexity of this solution? Now if you can see, like we are going n square. Perfect. N square again, and n. So overall time complexity will be O of n square. What is the space complexity? What is the space we are using? O of n plus n. This is O of n, right? So this is a simple solution. So code will be available in the GitHub. You can check out in the description. And if you found this video useful, do subscribe the channel, like this video and share the channel. मिलते हैं नई वीडियो के साथ, तब तक के लिए बाय बाय.